Hello everyone and welcome back to another screencast on shapes, congruent and similar. Now this is going to be easy peasy. That's right, lemon squeezy. It really is going to be ridiculously easy. I'm sure you'll find it, no problems. For those who really need a calculator, you'll need it probably once today. If you do not use it unless you absolutely need it, but maybe have it out if you really do struggle and you're doing the foundation IGCSE course where you're allowed to use calculators for both papers. So we've got congruent and similar shapes. The definition is equal in size. This is for congruent. Equal in size and shape. Two objects are congruent if they have the same dimensions and shape. Very loosely, you can think of it as meaning equal. And that's from Maths Open Ref. Similar. Two shapes are similar when one can become the other after resizing. Flipping or flip, slide or turn. Resizing if one shape can become another using resizing. mathsisfun.com. And I'm going to go through a couple of examples here. It really is that simple. So we've got a triangle here. I haven't put any measurements on it, but here we go. We've got a bigger one. All right. So what we'd say is the bigger triangle is similar to the smaller triangle because it's in proportion to each other. And what that means is the angles are the same. Yeah. Okay. The angles are the same. So roughly we can see we've got a 90-degree angle here, a 90-degree angle here. Let's say this angle was, let's go for 50 degrees. Yeah. Then this angle here would be 50 degrees, which then means that we've got 90, and that's 140. So we've got a 40-degree angle here. This would be the same. If this side here was, let's say, 2 centimeters, as long as this side here was, let's say, let's go for 6. Well, this is 3 times the size, which means that if this one is 4, then 3 times the size would mean this is 12. So they're in proportion to each other. And that's really important. Basically, this shape has been enlarged. So this shape here has been enlarged. That's why the angles stay the same, but the measurements change. But they all change to a certain amount. And that's called a scale factor of enlargement. So now we're going to show you congruent. So this triangle here is exactly the same as this triangle here. They're the same length, the same width, the same height. They have all the same interior angles, so therefore they are congruent. All right. Hopefully you've got that, understand that. We're going to go through them nice and slow. It's going to be a really quick PowerPoint, fingers crossed. So congruent. Okay, so like twins, they're exactly the well, arguably you might say, it's like identical twins. They're exactly the same. All right. Believe it or not, this shape is congruent to this shape. And you can see that, can't you? It's pretty clear that I could pick this shape up, I could place it back down directly over top of this shape, and they would be the same. Now, also, this shape is congruent. So all of these shapes are congruent. Just because it's been turned doesn't mean it's not congruent. That is really important. And one more example is here. This is also congruent. You might have to turn your screen to work that out, but they are of the same shape, the same size. All the angles will be the same. Okay, that's congruent for you. We're going to now focus on similar. So here goes some questions that we might, this is not a question, this is an example. Okay, so here goes, these shapes are similar. And it will say that in the question normally. These shapes are similar, work out the length of the side. Okay, but we can see here that these shapes are similar. The degrees are the same here and here, 40 degrees, 40 degrees. This degree is 50 and this is 50. This is 90, this is 90. This is 6 and this is 12. This is 3 and this is 6. So what have we done to get from 6 to 12? We've times by 2. What have we done to get 3 to 6? We've times by 2. So it has a scale factor of enlargement equaling 2 because it's twice the size in every way. Just remember, just because it's twice the length doesn't mean that the angles will change. That's something that a lot of people get struggle with. All right, so we're going to use this information to help us moving forward, going through these questions. But I feel very, very confident that so far you're getting this no problemo. All right, so what we're going to do now is I want you to use your common sense, and I want you to find out that missing length of the side. Okay? Do that now. Away you go. Okay, so here we go. How did we get from 2 to 6? How did we get from 2 to 6? We times it by 3. How do we get from 4 to whatever? Because it's similar, enlarged, yeah, we're going to times it by the exact same amount. So times it by 3, and what we end up with is 12 centimeters, okay? Because they're similar, all right? Now, sometimes we might need to go the other way, and that's the next question we're going to do. So here we go. You've got a shape, all right? You now need to work out what the missing length is. Pause the video now, give it a go, come back and see if you get it correct. All right, so we have gone from 6 to 3, and that has been divided by 2, or we've gone from 3 to 6 and it's been times by 2. But we need this divided by bit because we're taking the bigger into the smaller, and we can see that, yeah? So I've gone 6 divided by 2 gives me 3. 3 timesing by 2 gives me 6, but I don't know what I've got, so I can't times it by 2 because I don't know it, so I've got to divide it by 2. So what's 7 divided by 2? That is 3.5 centimeters. Okay? Very, very simple, I'm sure. Believe it or not, it's now time for the quiz. It's a very short PowerPoint. I'm sure you'll be absolutely gutted by that, but work out the scale factor, so how much it's enlarged by, and the missing sides and angles. We haven't even covered the angles, but we've spoken about it. So here we go. Here goes your two shapes. Work out those missing sides and the missing angle, which is here. Come back and see if you've got it correct. Okay, so here we go. Let's do it now. See if you've got the right answers. So we can see here that this is the same as this. So hopefully that didn't trick you up. How do we get from 12 to 4? We divided 12 by 3 to get 4. So if I divide 18 by 3, I get 6. So we've divided by, or we're times by 4 to 12 by 3. So timesing 9 by 3 gives us to 27, and that's the reasons why. So fingers crossed you did fantastically well on that. I'm sure you did. Write a little revision card up. What is similar? What is congruent? What are the meanings of each of them? And you have a great day, evening, or morning, whatever you're doing right now. Until next time, as always, it's a pleasure helping you with your maths.